Welcome back. Often there are questions about compounding and interest, and so we wanted to take a look at a couple of examples where we address this different ways. Actually, in this one example, we can look at both types of interest: compound interest, that is taken quarterly, and continuous interest. And so we need two different formulas for these. So notice what the question says. It says, suppose you have $20,000 to invest. Which of the two plans gives you a better return? The red plan, which is 10.88%, compounded continuously for 2 years, or the yellow plan, which is an 11% compounding that happens quarterly for the 2 years. So notice that the time is the same amount of time. We just want to know which is the better plan. It should be noted that if the rate was the same and the time was the same, that continuous compounding would give you a higher rate of return all the time, slightly higher rate. But that's not happening here. Notice that we've got continuous compounding happening on the lower rate, and we've got quarterly compounding happening on the higher rate. So we really do have a horse race here. We're not sure how this is going to go. We want to take a look. So let's take a look at the red plan. Here I've got compounding continuously. Now, as soon as you see the word continuously, you need to say, okay, well, that's going to be accumulated amount is going to be the principal times e to the RT. That's the rate times the time here. So for this part, we're just going to say, let's find our accumulated amount by taking our $20,000 principal, that's the money you start with, times e to the what rate? Now this is peculiar. Notice that it's a rate of 10.88%, but you have to shift your decimal twice, always twice, to the left in order to switch a percent into a decimal. So I'm going to put my rate as 0.1088 times the time, which was 2 years. We're presuming that this is, and it's not listed in the homework this way, but we're presuming that it's 10.88% per year. So we just literally want to go ahead and type this in. So I'm going to say 20,000 e to the 0.1088 times 2. And that gets me an accumulated amount of $24,861. 0.79465 is what comes out after the decimal, but keep your common sense engaged here, because we're going to write this as dollars and cents. And if this was a 5 or higher, I'd round up to the next penny, but it's a 4, so I'm just going to literally get rid of it. Okay. So we know what our red plan is going to give us. Let's go see what the yellow plan is going to do for us. For the yellow plan, it's compounding quarterly. Now that's important because that tells me that every quarter they're going to compound the interest, which means to scoop it up, pile it onto whatever the previous principal was, and then run my interest off of that. Now, in this case, we're compounding quarterly, so that means it's going to happen 4 times a year. Now, for this formula, I'm going to need accumulated amount. It's going to be the principal times the quantity 1 plus r over n to the nt, where P is still principal, R is still your annual rate, N is how often you're compounding in a year, and T is the time, how many years. So let's go ahead and take a look here. I've got accumulated amount, still 20,000 that I'm working with, 1 plus, better rate here. So be careful. This rate still has to go 1, 2 shifts over. So I'm going to say 0.11 over quarterly. So my N gets used twice. So the 4 gets used here, but notice that it shows up here in the formula again. So I'm going to say 4 times my time, which was 2. So I'm going to go ahead and type that in. So 20,000 times the quantity, 1 plus 0.11 divided by 4. Close the parentheses and raise that to the power of 8. I can go ahead and multiply that out. Usually that's an easy thing to do. So I'm going to get a total accumulated amount here of $24,847, and this one goes, whoops, this way. Now again, dollars and cents tells us to round to 61 pennies unless the very next digit, the very next one digit, was a 5, 6, 7, 8, or 9. Because it's just a 1 after that, I'm going to go ahead and literally just stay at 61 cents. And now I can compare the two plans. The red plan gave me $24,861. The yellow plan gave me $24,847. So in this particular instance, the red plan would be the better plan. We'd get a better return on that. There was one other thing I wanted to talk about as long as you're tuned in, and it's that not everybody has a graphic calculator. So if you don't have a graphic calculator or a calculator that runs the order of operations well, And I want you to be really careful when you're doing this formula. Most folks do just fine in the continuous compounding environment, but when we get over to here, if you don't have a graphic calculator, you need to make sure you follow these steps. When you're doing this problem, you have to first and foremost total what's in here in the parentheses. Once you get that, you're not allowed to multiply that by the 20,000 yet. This is the last move you'll do. So first we get our total here, and then we raise it to this power. So you literally take this, get that total, raise it to the 8th power. After you get that, the last thing you do is the 20,000 multiplied by whatever that was. A lot of students make a mistake where they go ahead and they get a total here and they multiply it by the principal, and then they raise it to the 8th power, and that's going to give you a completely different number, a way bigger number. It'd be great if that was true, but it won't give you the right answer, so be careful there. If you're doing it by hand with a regular calculator, inside the parentheses, and then your exponent, and then your multiplication, which, by the way, ought to start sounding familiar because in PEMDAS, or please excuse my dear Aunt Sally, we're always doing grouping symbols first and then exponents, and it's exactly why we have to do it this way. And then after that, multiplying and dividing. I sure hope this helps. Have a great day. Take care. Send me an email if you have more questions. Bye-bye.